So everybody, welcome to this awesome class. Today I'm going to be showing you how to answer NCRDR question. And if you are a network engineer, you should be able to work with this CRDR because whenever you are doing subnetting, you are not going to escape class side intent domain routing. This one stands for class side intent domain routing, something like that. So you are not going to skip this one. So and most CRD error is always go with slash, maybe like this. So for instance, they will give you maybe IP address and one like this, and then maybe they will tell you slash 22. If they give you IP address like this, and then they ask you what is the subnet mask. They already name the subnet mask of this IP address. So to answer this question, first let me just post some slides so we can be able to work with it. Because the benefit of this video is only to be able to answer any Slack question. So maybe we can say Slack 27, we can post Slack 30, sorry, we can post Slack 30, we can post Slack, let's just say 19, we can post Slack, maybe we can say like 16 or any other number. Okay, maybe we can put like 21, slash 21, something like this. Okay, we already have 22, so we can go just to slash 18. Yeah, just like that. So now we have 19, so 20 that this. Okay, so we can put like slash 29. So let's just any number they give you slash 29, just like that. So if they give you this slash, various slash, and then they ask you all of the following, yeah, and then they ask you what is the subnet mask of the following? How can you do it? How can you solve this problem? To solve this problem, first let me label our working tool. So we have 128, we had 64, we had 32, we had 16, 8, 4, 2, and 1. So we had this. These are just 8 authors. Everything here is equivalent to this number called 32, 32-bit. Everything here is equivalent to 32-bit. So now, how to answer this question like this one? We need to write 22 ones. So to do it, we have 1, 2, 3, 4, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 16 already. 17, 18, 19, 20, 21, 22. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So now you see, I put this number, I put this number, I put this number, I put this number to 1. So everything is equivalent to 32. Yeah, 32-bit. So now, how can we, sorry, everything is equivalent to 2, 255. Yes. And this one, everything is equivalent to, if you write like this number, for instance, you write this number like 8, 8, 8, and 8, R will be equivalent to 32-bit. So everything that we land out here from this zero, from this ones to this zero, R is equivalent to this 32 because this is 8, 8, 8, 8. If you add all of this number, it should be able to give you 30, 32. So now we have, and they ask for out of this 32-bit, we should be able to put 22 ones on so we can find a subnet mask. So after we put 22 ones, because this one is 8, this number is 8 here, this number is 16, 17, 18, 19, 20, 21, 22. So now the answer for our question is we are 255, 255 because these 2 bits are already on. This 16-bit, it is the same 16-bit that we have here. So now we need to carry on this calculation by this, and this, and this. So I will use, that means just first use only my calculator, then I will use and the other calculator later. So now let's change it to standard calculator. Okay, so what we can do, because we had this is let me just say this is This is, and this one is, this is, sorry, this is blue. This is this one. This is yellow. This one is, maybe we can say green, and the last one will be, we can consider this one to be like this. So you see, everything that these ones that are colored, then it will be the number that we are going to ask. And we know this is 1, 2, 3, 4, 5, 6, 7, 8. And it's the senior 1, 2, 3, 4, 5, 6, 7, 8. So this one is in the place of this 22, 128, this one for 64, this one for 32, this one for 16, and this one for 8. So what you need to do, just add all of this number here. So we will have this number, one. So let's say, okay, let me use my little calculator, but you can just add them this number here, this number here. I know here. Starting from here. You can just add them. So now let's say, uh 128 plus 64 plus 32 plus 16 plus 8 plus 4. Yes. So R should be equivalent to 252.0. This will be the surname mass of slot 22. So now we can go back. In fact, we can go to the next one, which is slot 27. Yeah, slot 27 is here. So we'll put 27 once. 3, 4, 5, 6, 7, 8, 8, 1, 2, 3, 4, 5, 6, 7, 8, 16, 1, 2, 3, 4, 5, 6, 7, 8, 24, 25, 26, 27. So 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so it will be like this. Let me just bring this one down a bit so we can be able to see it. Yeah, something like this. So you see, we have like top 27 ones. All of these ones, if you add them, they will be the 27 ones. This is how you can do it. So the next thing here, we already know we have 1, 2, 3 uttered on. So 255, the 255, the 255. So the last one, in fact, 1, 2, and 3. So I have 1, 2, 3, 4. Okay, sorry, I don't have to write this one. So we only have 1, 2, 3, and 4. So we already have 3 author on. So we need to add this number, 128 plus 64 plus 32. So this one is 128, this is 64, and this is 32 here. So everything will be equivalent to 224. So this is the answer. Slot 27 always carry 224. So we can do the same thing for 30. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, 27, 28, 29, 30. So 0, there's 2. So now we have 1, 2, 3, and 4. So next thing we need to do, we need to do the same thing. So now we will add all of this number here. So we will have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So 4, which will be equivalent to the same number here. So this is 128, 64, 32, 16, 8, and 4. 8 and 4. So it will be, they will be in the same range also, which will be 2, 5, 2 here. 2, 5, 2. So the next thing we need to go to slot 19. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 16, 17, 18, 19, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, and 4. So we can do the same thing. 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. So now, because we are working with this one, So we need to add 128, 64, and 32. It will give us 190 something. So, uh, two something. So 128 plus 64 plus 32. So we should be around 224. So this will be 224 slash 0. So you see we have 224 here and we have 224 here, but because this one we have 0 behind and because this one are all 0. So the next thing we need to do here, we can do the same thing with this one. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 24, 25, 26, 27, 28, 29. So now 16, 16, 2, 4, 5, 6, 6, 7, 8, 24, 25, 26, 27, 28, 29, 29, 5, 6, 7, 8. So 29. So now we are only working with only this one here. So our next sub numbers will be 255, 255, because we have this three orchard is already on. So here will be our work. So we'll add other days number 128, 64, 32, 128, 64, 32, 16, and 8. We will add this number. So we have 128, 64, 32, 16, and 8. 128, 64, 128, 64, 32, 16, and 8. So it will be equal to 2, 2, 4, 8, 248. So guys, this is how you can be able to answer any CRD question. So whenever they give you a slot, slot 20, slot 22, any number they give you, just make sure and go by this little idea that I gave you. I think once you can do one or two, and maybe you can even do 3 to 400. Is that nothing? So everybody, this is how you can be able to solve any slot question when it comes to computer networking or subnetting. In our next video, I will be teaching you guys how to carry on OSPF configuration and also RRP configuration. Thank you. Please don't forget to subscribe to my YouTube channel. Send me your comment so I can be motivated to know what is going on and also to be able to do more video. Thank you very much. See you in the next video that I will create. Thank you.